When you look up at the night sky, it feels boundless. It is easy to look at the sheer density of stars and assume the universe is an endless open ocean, completely available for us to explore if we just give it enough time and technological progress. But the mathematics tell a much harsher story. Even if humanity eventually unlocks the ability to travel at the speed of light, 94% of the galaxies in the observable universe are already unreachable. We will never be able to touch them, no matter how hard we try. This loss is happening constantly. Every single second, 60,000 stars cross an invisible cosmic border, slipping away from our reach permanently. Since you started watching this video, roughly 22 million stars have quietly exited our potential sphere of influence. So why is the vast majority of the cosmos locked away from us? And if those galaxies are already gone, how are we still looking at them right now? The answer starts a fraction of a second after the Big Bang. About 10 to the negative 36th seconds into its existence, the young universe was a tiny bubble of energy, but it wasn't perfectly uniform. Some pockets of this bubble were slightly denser. As this diagram shows, those tiny differences had massive consequences. In a process called cosmic inflation, the universe rapidly expanded from the size of a marble to trillions of kilometers in a trillionth of a second. That violent stretching turned microscopic gaps into massive galactic-scale empty spaces. After that brief period of inflation ended, gravity began pulling matter back together. Inside those slightly denser pockets, gravity won the tug-of-war. Matter clumped up to form tightly grouped clusters of galaxies, including our home, the local group. But outside those localized pockets, the expansion of space never actually stopped. The empty voids are still expanding between them, actively pushing our galaxy group away from the others. Gravity successfully anchored our immediate galactic neighborhood together, but it failed to connect us to the larger cosmic structure. We are permanently isolated in our own pocket. Making matters worse, this expansion is actually speeding up. We call the invisible effect driving this acceleration dark energy. This model illustrates the resulting cosmological horizon. Because the space between us and distant objects is expanding, everything past this boundary is physically receding from Earth faster than the speed of light. If they are moving away faster than light, why do we still see them? It is simply because light needs time to travel across the universe. The light hitting our telescopes right now was emitted billions of years ago, when those galaxies were much closer to us. The night sky is filled with ghosts. We are looking at the ancient positions of galaxies that crossed the horizon a long time ago. There is roughly 6% of the observable universe that is technically still within our horizon, but even if we could travel at light speed, reaching the closest neighboring galaxy group would take 11 million years. The universe is pulling off a grand illusion. It puts on a spectacular show of brilliant galaxies and ancient superclusters that we can observe from afar, but will never physically interact with. Billions of years from now, our local pocket will consolidate. Gravity is actively pulling our Milky Way and the neighboring Andromeda galaxy on a collision course. All the galaxies in our immediate vicinity will eventually crash together to form one giant elliptical galaxy, a final, tightly bound cosmic home known as Milkdromeda. By the time that happens, the accelerating expansion of the universe will have done its work. The galaxies outside Milkdromeda will be pushed so incredibly far away that their light will completely fail to reach us. Imagine the perspective of a future civilization born inside this giant merged galaxy. When they point their telescopes out into deep space, they will see absolutely nothing but a pitch-black void. They will have no cosmic background radiation to study, no galaxies rushing away from them to prove the universe is expanding, and no remaining path to discover the Big Bang. To these observers, the universe will appear to be a lonely island in a dark void, leading to the false conclusion that their home is static, unchanging, and eternal. This makes our current moment incredibly rare. We are lucky enough to exist in the exact fading window of time where the evidence is still visible. We get to look up and see the deep past, understand the expansion of space, and know the ultimate limits of our universe before the lights eventually go out.